In this video, we'll introduce electrical design by talking about circuit schematics, and in particular talking about the vocabulary we use to describe circuit schematics. We want to do this because we conceptualize almost everything in electrical engineering in terms of circuit schematics, like the one on the left. Ultimately, we want to turn these into devices like the one on the right, which move electrons around in some specified way, but in order to do that, we need to be able to discuss our ideas and understand a schematic as presented to us. To do that, we need a common language. So in order to build a vocabulary for how to describe circuits, I've drawn a large circuit here, which we'll start taking apart. One way to disassemble it is to note that it's composed of many pieces which look the same. For example, there's this piece and this piece, which are drawn with the same symbol. Each of those pieces is referred to as an element. So simply put, circuits are made up of elements. Elements connect to the circuits at a number of points. For instance, this element connects here and here, and this element connects here and here. The points where an element connects to a circuit are referred to as terminals. If an element only has two terminals, they're called positive and negative. However, some elements have many terminals, and those have different naming conventions. Each element has a name, which is used to refer to it. So for instance, the first element I underlined is called R1. The second element I underlined is called R3. This different looking element is called L1. Sometimes elements will also have values associated with them. For instance, R1, R2, and R3 are all the same kind of element referred to as a resistor. And resistors have a value called a resistance, which is associated with the element. Often in equations, you'll just use the element's name as a stand-in for its value. So, for instance, I might write the equation V is equal to I times R1 in order to refer to the value of R1. Elements connect to each other at nodes. So, for instance, R2 has a terminal which is connected to node C, as does L1. R1 has a terminal which connects to node A, as does R2, as does R3. Similarly, node B is connected to three different resistors, R3, R4, and R6, each of which have a terminal connected to the node. It's a common misconception to think of a node as a single point on a circuit. So for instance, like this dot I drew for node C, or like a dot I could draw for node in. However, in reality, a node just refers to a place where many terminals are connected together. So seeing it drawn as a big long line is not uncommon. That is to say, put another way, you can think of nodes as being separated by elements, which means that this point, and this point, and this point, and this point are all part of the same node, the ground node, because there's no elements down there to separate them, whereas this point and this point are separated by an element, R5, and therefore are part of different nodes, ground and D. If we look at one specific node, there are a number of paths that go into or out of it. So for instance, looking at node D, there are three paths where I'm drawing arrows. Each of those paths is referred to as a branch. So the number of ways into or out of a node is referred to as a branch. Finally, a port refers to an interesting pair of points in the circuit. So for instance, adding a port across in and ground would be very common. That would be an interesting point to measure because, as suggested by the name of the node in, that's considered an input to the circuit. Similarly, we could add a port to measure some output across node C1. So let's test our understanding of this. How many nodes are in the circuit pictured below? The correct answer is 4. There's one node that connects V in and L, one node that connects L and R1, one node that connects R1, R2, and C, and one node that connects B and R2 and C. Testing again. How many branches leave the node labeled out? The answer is 3. Since this question refers to a specific node, we know we're talking about branches, which is paths into or out of a node. And if we look at node out, there are 3 paths, one through C, one through R2, and one through R1. The key points of this video are that schematics describe circuits as a collection of elements which have their terminals connected to nodes. These elements may have values, and their names are often used as variables to denote that value. Branches describe paths leaving a node, and ports describe interesting pairs of points in the circuit.